according to the IRS, the average length of time for an individual to complete the IRS is 10.74. And let's assume that the standard deviation is 2, and we're randomly surveying 36. So because we're finding the probability about an average, we're going to use standard error, which is sigma over square root of n, which is 2 over square root of 36. Use your calculator and you get 0.33333. Okay, so to find the probability, we first graph it. So here's 10.74 in the middle, and 12 is out here, more than you would shade to the right. The second step is to use the z-score, so x bar minus mean over standard error. So we have x bar, which is 12, minus mean, which is 10.74, divided by 0.3333. So 12 minus 10.74 divided by 0.333. Well, let's do 12 minus 10.74 in your calculator first, then divide that by 0.333, and you get 3.78. Now 3.78 isn't on the normal chart, so you want to choose a value that's closest to 3.78. So a value that's closest to 3.78 would be this, 3.49. So that's a 0.9998, so you can assume yours is like 0.999. I mean, you could use 0.998, but I'm assuming it's even larger than that because it's 3.78 instead of 3.49. So let's assume that's like 0.99999. But that does not look like 99%, and that's because the area goes to the left on the chart. So you have to do 1 minus 0.999, which gets you something very close to 0. And so you would be very surprised if it took the taxpayers 12 hours or more. And then, actually, that's the end of the question. To graph it, or it doesn't have you graph it, but it's normally distributed. You put your mean and standard error here. X bar always stands for the average length, or the average, and X is looking for what you're actually looking at. So in words to find what X is, well, it's the length of time for an individual to complete. The length in time, and it's in hours. Length of time in hours for an individual to complete. And so X bar is the average length in time in hours for the 36 taxpayers to complete the IRS form.